Okay, good morning, good evening, good afternoon, depending on where people are. Hopefully you can hear me. Yep, great. Okay, let's see. Well, we're going to give just a few minutes for people to join. And we should have plenty of time. I don't see us needing the full 2 hours. My guess would be we'll take closer to 1 hour, maybe a little bit more, with the switching from one presentation to the other. But anyways, let's gather for a little bit longer. For those of you who are presenting, in order for you to present, you'll need to be able to get into the queue to share your audio, your video if you like, and to share your screen. And then you should be able to drive the presentation from your end. If you prefer and you uploaded your presentation to GitHub, I could probably download it and drive it as well. But if you're able to share your screen, I think that's probably the easiest way to do it. What's kind of seems to be working for me is rather than enter into presentation mode for a presentation, though, I kind of keep it in non-presentation mode. That way it doesn't take up the whole screen. And while the viewers can't see it quite as big, at least I can still see my Miteco screen and a bit of what's going on there. So you can see what works best for you. I'm going to try it this way this time and see how that goes. Great, I see we still have more people joining, so I'm going to give it, I think probably at 7:05, we'll get started. Just to give you an idea of, here's the current list of presentations that I do have. I believe there are now 10 presentations. We're going to stick to the 5 minutes, but like I said, we should have some time at the end, both for general discussion and if we need more time, if someone wants to talk more Q&A about a project. When you're presenting, if you want to take some questions on your project, that's fine. Just plan on that being part of your presentation time. So finish your presentation a bit early so that you can entertain questions for the last portion of your 5 minutes, because we are going to try to keep each presentation to 5 minutes just to keep things flowing and to be fair to everyone. For me, it's early in the morning, but for some of you, I realize it'll be late on your Friday and you probably have other things to do as well. We are recording this session, which is great. It'll be available afterwards. Because there'll be a lot going on, and I'm sure I'm going to miss some things and want to be able to review it. So it'll be good to have that record. Okay, I think I'm going to go ahead and get started then. So welcome to the closing session of the hackathon. And I hope you've had a good week. Certainly things have been different with doing this online. And hopefully, while some things are not as good as in person, hopefully other things actually worked out better, especially for remote participants. I imagine when everyone's remote, it might be a little bit easier to work with each other. So just a reminder, hopefully you all caught the opening, but for those of you who didn't, a couple quick reminders. One, just the reason we're here, right? And really the goal here is to move all the valuable work that we're doing in the IETF forward at a faster rate by bringing people together, working on not just the drafts that we're writing, but to write some code that verifies what these things are. We're standardizing these new protocols, new fields, new things for the internet that are going to make it faster, more secure, better privacy considerations, everything about the internet really, and be able to flesh things out early. And not only that, but also produce some, hopefully some handy tools and utilities, things that'll make it easier for other people when they go and try to add support for these new standards, protocols into their products, into their solutions, so that we really get not only just a larger set of written standards, but we get more solid deployments out in the market quicker of everything that we're standardizing in the IETF. We're operating under the note well, as all IETF meetings do. So the presentation certainly that you're doing now will fall under the rules of the note well. Hopefully you're all familiar with it. If not, you can take some time to check that out as we get started here. So the presentations, as I mentioned, we're going to keep them to 5 minutes, really focusing on lessons learned, the feedback that hopefully you'll be able to bring into your working group, assuming they're meeting this coming week, or if not, via the mailer or when you have your next interim meeting, so that you can help move the work of the entire working group forward. And it's nice to know about open source projects that perhaps you contributed to or used, or that you worked with. If you crossed SDOs, obviously there's things important to IETF that are going on elsewhere, be it in open source communities or in other SDOs. It's interesting to hear about that. So just some suggestions of things you might want to mention. This is the list of projects. The plan is to go through them in order, and hopefully the person I have is the right person who will be presenting. If not, you can let us know via the chat or just by entering the queue. And Lorenzo and the folks from IETF are going to help me a bit with the queue management, so that we can make sure that you're able to speak and share your screen. So. So yeah, when it's time for you to present, make sure you get into the queue. And when we see you enter the queue, we'll be able to unmute you. Or if you have some questions near the end of our presentation, if there's time for Q&A, make sure you get into the queue, and we'll be able to acknowledge you and then give you the floor so you can share your question. Okay, so with that, I think we'll start with Walter. And if you want to share your presentation.
Okay. Can you hear me and see my screen?
Yep, can hear you loud and clear. Sounds good.
Okay, thanks, Charles. So this is the presentation of the project that we titled Multi-Level Approach to IBN. This actually was the first time the Network Management Research Group of the IETF has been presenting something at the hackathon. And being this based on activity from an IETF group, is, let's say, less focused on standard or specific implementation of any IETF solution, and it's more related to research or main idea and architectures. And actually, this is what we've been discussing. In particular, the problem we were working on is about intent-based networking. For those of you who are not familiar with this approach, basically the idea is to define this intent as a set of operational goals that a network should meet and outcomes that a network is supposed to deliver, defined in a declarative manner without specifying how to achieve or implement it. So basically, the idea is to move from a more prescriptive approach, which is the traditional way where you configure and manage your network, to something different, something that is more declarative. And this is how all this idea of intent-based networking comes into play. There has been some activity. There have been some activities within the NMRG research group about this, and this brought to a couple of drafts that are currently being in development. One is about trying to define what is actually an intent, so having concept and definitions, as well as some discussion on how an intent is different from policy-based network management and service management and service models. And then also there is another draft about intent classification. So those are the references for those of you who want to get more about this. So what in specific we wanted to solve in this hackathon? We wanted to understand if we can apply the intent concept at different levels that basically correspond to what you can have as different stakeholders. Consider the case where you have an infrastructure provider, so you have service providers that wants to use some or reserve a slice on top of that infrastructure, and then customer or verticals that are actually using that slices. So basically, we have infrastructure provider that provides some sort of slice intent interface. The service provider is supposed to consume this slice intent interface and provide on its turn a service intent interface, and then customers or vertical who are actually interested in running the services to consume that service intent. So what we actually wanted to do is to understand if this is something that is viable, that is possible to do with a proof of concept built on a network function virtualization framework. We've been using basically OpenStack as a virtual network infrastructure platform, and open source Mano as an NFV management and orchestration tool. So the idea was to actually demonstrate how we could actually set up defining specific intent at the two levels that I was mentioning, slice intent and service intent. And of course, we did this in a very simple scenario with a single point of presence for the virtual infrastructure. So what we were able to do, actually, we successfully proved the concept. We successfully completed the demonstration. Actually, the work on this demonstration was a joint work developed by myself and one of my PhD students at the University of Bologna in Italy, as well as other colleagues at CNIT in Italy. Those activities were actually part of the work that we made in the framework of the network management research group in the last year, more or less. After this kind of hands-on demonstration of the concept, we were able to have a fruitful discussion on the next steps to be done within the NMRG group, especially integration with high-level intent expression translation techniques, and also to apply the methodology for the intent taxonomy classification, which is the topics of one of the drafts I was mentioning before. If you are interested, we recorded the session. It lasted a little bit more than 2 hours. So you have the link here where you can download and see the video recording of the presentation. What we learned is basically IBN is still a greenfield in terms of research. There is still a lot of things to do, and this is basically the main message that we would like to share with our research group, that we really need to bring together a diverse background and expertise, because we need to integrate people that works on language, on for intent translation refinement, people that works on validation or on machine learning in order to learn and understand if things are going. So all the points that you see here, those are really needed in order to build a real IBN system. So basically that's all. I would like just to thank the guys that helped me in running this presentation and this demonstration. Again, you have the link here for the video recording if you are interested to. And if you want to know more, there will be the NMRG meeting next week on Wednesday, and this is the link to the agenda. And I guess I'm done.
Great. Do you have a slot in that agenda to actually talk to that community about what you did here, or plans to share that?
Yes, the group chair asked me to report on the result of the hackathon session that we had on Wednesday. So we will be discussing, and I will bring that message to the group.
Terrific. Don't see anyone in the queue with questions, so why don't we go to the next presentation? Wei-Hong Wu on iFit and IPN6. Great, we can see your presentation. I see your video. Don't hear you yet.
Oh, okay.
There we go.
Okay, let's start. Hello, everyone. My name is Wei Hong, and I'm a PhD student in Beijing University of Post and Telecommunications. My major is about SRv6 and operators. One was looking for some solutions about the closed-loop traffic control. I noticed iFit and APN6 and had some interest in them. So we read some documents and developed both a demo for them. This slide shows the main works and some useful links. For the works, the one is implementing the demos based on P4, and the other is conducting some simulations based on BMV2. The BMV2 is the virtual switch of P4, and the links include documents of iFit and APN6. We also show the links of the APN6 community in GitHub. Well, some days ago, somebody asked the meaning of iFit and APN6 in the mail list, so here we think we should introduce them briefly. As just mentioned, iFit and APN6 can form a closed-loop control system. iFit takes charge of the in-situ telemetry. It supports diverse types of data and the dynamic configuration for indicating them. APN6 is an application-aware traffic control scheme. It can convey users' requirements through the IPv6 extension header, or SRH. There are two essential functions of the iFit demo. The one is the encapsulation of IOM options to specify desired type of data, and the other is the obtaining and uploading of specified data. One document of iFit mentions that there are two modes of IOM telemetry, namely postcard and passport. In postcard, the IOM data is obtained and uploaded by transit nodes, while in passport, uploading is responsible by end node, and the IOM data is transmitted along with user's payload. The next is APN6. It presents some hop-by-hop options to indicate the requirements and can determine the control according to these options. We implemented two types of options to identify the application information and four types of sub-TLV to indicate the performance requirements, namely bandwidth, delay variation, and packet loss ratio. We've implemented the demo based on P4.16 and conducted some simulations based on BMV2. Here shows some realized functions. In iFit, we implement both postcard and the passport, and both include the encapsulating of IOAM options and the obtaining and uploading of IOAM data. In APN6, the core functions are the encapsulating of the mentioned options and sub-TLV and the differentiated SRv6 seed list determination. In APN6, we also implemented some related essential SRv6 processing. Well, we've conducted some simulations for iFit and APN6 functionally. We've uploaded the simulation videos to OneDrive, and here are the share links. Well, the next period we plan 2 main works. The one is transplanting these demos to the barefoot to Fino switch, and the other is deploying the transplanted demos on Cine. Cine is a large-scale cross-domain experiment infrastructure for some novel network schemes. It's still under construction, but at present some nodes have been already used. And finally, if you have some interests or puzzles about the demo or any others, just contact us. So maybe that's all. And thanks for listening. Hope to see you again.
Great. Well, thanks for sharing that. I believe I saw your presentation already uploaded to GitHub as well. If others wanted to take a look at that. So yeah, thank you much. Let's see. So next up, Sylvester on quick measurements. Okay, we can see your slides. We don't hear you yet. You should be able to put yourself in the audio queue. If you look at the little microphone with a hand on it, if you press on that, there you go.
Okay, so I had to enter to the audio queue and the video. Can you hear me now?
Yes, and we can see you as well.
Okay, thank you.
And your slides. All good.
Nice. So I'm presenting for the quick measurements group. We are working on a tool called SpinDump. And the goal is to provide tools and ideas for traffic measurement in the area of encrypted transport. It's for debugging, research, network health monitoring, optimization, and network management adjustment. And what we did is that we did updates to the SpinDump tool, and we also discussed how to evolve the SpinDump tool and how to do updates to it in the future. So what got done, there were many small updates basically. So we worked on traffic classification to find out what percentage of my traffic goes to Facebook, for example. So SpinDump is from being a spin bit measurement tool, we are evolving it to be a more general measurement tool, but still the main focus is quick, but there are many other things involved. We are working on model generation for simulations to get connection data, get more information about the connection, and be able to use it for example, traffic modeling. We are discussing how to give the power for observation to the client, how the clients can opt in for measurements. There will be a HotFC presentation about this idea. We are thinking about how to measure SRT. There will be a slide about that. We are working on a converter for QLog. We updated the explicit packet loss measurement part. There will be a slide on that also. And there is a maintenance for new versions for all the new OSs, which was involved from other people. We had to do some updates for the tool to be working. And also working on maintaining the tool to keep up with the quick improvements. So for model generation, we added the possibility of connection statistics for each closed connection. And what we actually implemented for that, there is a part of the connection statistics here. You can see a logarithmic histogram here, which can be also exported to JSON and plotted in outside tools. But you can see the heat map of the left RTT and the right RTT here. About SRT, SRT is a secure, reliable transport protocol. There is information about this, and people working with SRT got familiar with the tool and thinking about how to make the tool being able to measure SRT as well. And about explicit packet loss measurement, during the hackathon, the observer was implemented inside SpinDump. The testing of the methodology is using QuickGo to generate traffic. And the next step is to compare the results and also the general methodology with other explicit packet loss methodologies. You can see more information about the method itself and the implementation of the QuickGo is also available. So in this, the client generates a qubit signal and reflects the received qubit signal using the R-bit signal. And the server does similar things in the opposite direction. And using these signals in the midpoints, it's possible to derive packet loss happening in the network. And wrap up, we had quite amount of team members working on different things. There were a few more interested who actually didn't make it this time. I'm not quite sure who was first timer, and you can see our results in the GitHub repo, and there are some pull requests still being handled. And that concludes my presentation.
Okay, fantastic. Well, thanks for sharing. It's good to see continued progress on SpinDump and the measurements around Quick. So yeah, congrats and thanks for sharing.
Thank you.
Let me see, who do we have up next? Looks like we have Krister on NTS. So Krister, if you haven't already, you'll need to enter the queue. It looks like I can see your screen coming up, okay?
I had to press a lot of buttons to make everything work. Can everybody see the presentation now?
Yep, your audio is a little faint, but I can hear you.
Okay, I'm not sure if I can do much about the audio, so I'll just...
It's probably okay. It sounds a little clearer now.
So, network time security. It's NTP with security. This hackathon was, in a way, rather uneventful. Nothing much has changed, but the draft has been accepted. It's waiting for the RFC editors to become a proper RFC. There have been some minor changes to the draft just before the draft was accepted, and basically we've verified interoperability after the changes. And also the hackathon will sort of see if we can do something useful on some other front. So what did we do? Well, more successful interoperability tests. All implementations talk to each other, so no big issues there. There are the big star of this hackathon was Miroslav, who's the developer of Crony. He built a tool to be able to do sort of compliance testing with the draft of the NTS key exchange part. So he identified some issues, and some implementations also even managed to fix the issues during this hackathon. And the results, we have sort of a Google sheet with lots of a big compatibility matrix, just results from Miroslav's tests, and you can see the link down there. But the Google sheet is a bit too big to show here on the slides. So just trust me when I say that most of them do work. And as I said, Miroslav wrote a MTSK testing tool. It can be found on GitHub. Most of the fails that we see or most of the fails that his tool reports are due to implementations being too lenient. They accept things that don't have to be accepted by the specification, so by the draft. So we ought to tighten them down, but it doesn't sort of break anything. It's just that, for example, my implementation still supports TLS version 1.2, because we have older clients using TLS version 1.2, and the draft was changed to say, okay, TLS version 1.3 only. There were also a few bugs. I had a small bug that I needed to fix, but also that the bugs we've seen mostly affect corner cases, so they don't really happen in real life. It's more if we try to provoke things. And what we learned, well, automatic testing tools are really useful. Being able to run them over and over again and see, okay, have things improved? Have they gotten worse? That's really good. And well, as I said, interoperability is still good. Everybody is strict in what they send, maybe a bit too liberal in what they accept. And we did still have problems with firewalls. It seems that, or a couple of years ago, there were some big denial of service attacks using NTP as an amplifier to increase the traffic towards a amplified traffic from an attacker. And many ISPs have put in firewall filters trying to stop this. And I think we're still hitting those. So for example, Dieter had problems reaching one of the servers in Germany. I think Kai had problems reaching some of the servers Phil had problems reaching some servers in Germany. So we still have issues with misconfigured firewalls on the internet. And here are the people who were present on Slack during this week. And I should have put Kai as a first timer, since it was his first time in the IETF, but well, he ended up in the team members. And on the right, you can see links to the different GitHub repositories. And I think that's it. Any questions?
Great. Well, thanks for that presentation. Let's see. If I don't see anything in the queue, any questions in the chat, let's see. Karen mentioned, as a side note, the NTP work group is working on an alternate port draft. Okay. Well, great. Thank you very much. The next presentation is L4S, Tom Henderson. Okay, we see your screen. We see you.
Okay, can you hear me now?
And now we can hear you. Yep. Great.
Great.
Good. Go right ahead.
All right. Okay. My name is Tom Henderson, and at this hackathon, I organized some L4S work, and I'm speaking today from the Seattle area. And what I'd like to do before I summarize some of the lower level goals we had, just talk about the big picture of what we were trying to accomplish. So we're working on the low latency, low loss, scalable throughput architecture, which is being developed in the IETF transport working group. And to date, there's been a number of evaluations that have been conducted using small physical test beds. And what we've been trying to work on at this hackathon are some additional evaluation platforms, besides standing up a number of physical machines and cabling them together. First of all, NS3 is a discrete event network simulator, and that's the project that I'm mainly associated with. And discrete event simulation really is well suited to evaluating congestion control architectures such as L4S, and it has some complementary benefits to physical test beds, including much easier accessibility to just run a model of a network on a single machine, and the ability to introduce various wireless models which are going to be relevant to the performance of something like L4S. And in addition, being able to find and cable together a number of physical machines to do testing can also be a hindrance So we had a different group working on how to use a shared testbed, which is remotely accessible by network, namely Cloud Lab, to offer remote access to physical or virtual machines that then can run the L4S kernel code. So we had a team that had previously published some L4S relevant simulations on Cloud Lab, and so we'd asked them to maybe organize some scripts and documentation that would enable others to be able to reproduce similar experiments in that kind of environment. So that's the bigger picture. The detailed things we're working on were that we have a number of summer students on the NS3 project that are working on various aspects of the L4S architecture. So we wanted to bring some of that work together and push it forward, as well as this testbed configuration effort. And I mentioned a couple of the drafts here that are in the transport area. If you want to learn more about this. This has been the subject of previous IETF hackathons, but with different team members who were more involved in the Linux kernel code at that time. The specific problems that we were working on, a lot of integration of these different pieces. We have a model of TCP prog. The student there was working on the RTT independence feature that was recently discussed at the TSVWG interim meeting. Previously we had done a dual queue model. We had a student that has introduced L4S features into the FQCODL AQM. So we put that into our integrated code base. And we wanted to create an experiment with the integration of all of these different NS3 models that have been developed on different forks of the repository, and then try to start validating this simulation against the Linux testbed results. So the main thing that we were able to do this week is to produce integrated Git branches with these different components, putting them together for the first time in some cases. Our ultimate goal is to get these into our mainline. Next release is scheduled for the September timeframe. And so I've posted a couple of branches here that are where all of the code from this week's efforts reside. We also have published some scripts and documentation for creating this L4S testbed on Cloud Lab, and the link here in this from this presentation will take you there. I also have a summary wiki page that provides more instruction and details of how you can basically run all of these types of simulations at home. We haven't done any interop at this hackathon. We do plan to do some, and in fact, NS3 can be put into an emulation mode, and we could actually run the NS3 TCP models against the Linux kernel models at some future date, but we didn't accomplish that at this hackathon. Not a lot learned from the perspective of taking this, quirks or bugs, bug reports back to the working group. It's mainly was more of an integration effort and trying to get a lot of this code to run together. I think the main feedback probably out of this session to take to the working group, and I'll ask maybe an advertisement be made at the meeting next week, is that we do have these new testing capabilities coming online. And then finally, before I escape out of there, I just want to mention all of the people. Most of them were first timers at the IETF hackathon. We had a postdoc and a graduate student from NYU Wireless, Freda and Ashutosh, and then the rest of the participants have been are the students that are involved in the NS3 project this summer. And that's all I have.
Great. I see there was one question from Sylvester. What bottleneck speeds can you measure in NS3 and or Cloud Lab? Is there any limitations?
So the bottleneck speeds that we've been evaluating so far have been similar to the speeds that were used in the L4S, previous L4S test bed. So they were on the order of 50 to 100 megabits per second. We don't really have much of a limitation in simulation of scaling that up. I personally can't answer the question in terms of how far you could push the Cloud Lab infrastructure. So I'd have to defer answering that.
Okay. Well, great, thanks. Next up, we have Thomas Graff, BGP monitoring protocol. Okay, don't have your audio yet.
Okay, can you hear me?
There we go.
Okay, perfect. Thanks a lot. I'm presenting for the BGP monitoring protocol group. We've been working together since IETF106, improving the BMP implementation and the lab setup where we are testing. This time we were focusing on the correlation between BGP logcrip and IPFix, and also in the verification and interoperability of some TLV extensions to BMP, focusing on path marking and the route policy attribute tracing message type. Besides that, also we want to monitor and understand the impact of BMP in terms of CPU and memory consumption on the route processors, and also in case of BGP route propagation delay. We've been using PMA CCT for the data collection part, Apache Kafka as a message broker, Druid as a time series, Pivot for the user interface, and the BMP dissector of Wireshark for the deep packet analysis, and Spirent for the traffic and route generation. There is a nice tutorial in case you want to set it up by yourself. This was the lab network we were using. This is an MPLS VPN network, which is more or less the most challenging in case of getting the data correlation right between IPFix and BMP. From a lab perspective, this time new was the traffic generation, and also that we had with Young Push insight on the CPU and memory consumption on the routers. We understood that we need to further automatize the test setup. So far, it was focused on the orchestration itself. The next time, we want to put also into the test verification some automatization in. And also, especially, we want to leverage BMP itself to measure the propagation delay throughout the network. On the PMA CCT side, we achieved the BGP logcrip to IPFix correlation with prefixes with BGP route distinguishers. We are on the way of decoding all the TLVs on the route policy attribute tracing. And we identified, let's say, one optimization possibility on the path marking TLV when multiple paths are present, that we could index them and basically gain the possibility that we don't have to mark all the paths within the BPDU when we don't know all the paths. This is an example of a correlation between BMP, BGP logcrip with IPFix, where we see the route distinguisher of the VRF and the BGP community attributes for a certain flow. On the router side, pretty much we had everything supported this time, all the TLVs needed for the path marking and the message type for the route policy attribute tracing. We did perform stress tests and saw some increase on memory in CPU, but we recognized that the way how we measured the CPU increase seems to be not realistic, and we need to redo that for the next hackathon. The Wireshark dissector, which we did for roughly analyzing basically the new TLVs and message types, worked very well. This is just an example graph measuring the CPU increase. This before BMP enabled, after BMP enabled. As I said before, that's not very realistic. This is about the memory increase. So it's expected when you enable BMP that you have a slight memory increase due to the buffering needed when you have high congestion on the network. And we didn't measure any propagation delays or very minimal. That's how the decoding in the BMP dissector of Wireshark looks like for the route policy tracing, for the path marking. The BMP dissector of Wireshark, the code is committed. By any hour, it should be a build should be available on the Wireshark website. Next step is that also the path marking is supported. We had Livio from the ETH University, master student on board, who was working on the visualization of the BMP data. He was using D3 on the front end side and plywood on the back end side. This is the whole end-to-end chain he was using. So PMACT on the data collection, Kafka for the message broker. What we learned is we had quite some first-timer on board. They were quite refreshing. They brought in new ideas. One small example was why not make it possible that we can correlate BFD events with the BMP peer up, peer down message types. Let's say the young push gave us quite some detailed granularity into CPU memory. That helped a lot. The bad thing, since it was virtual, there were no beers and cocktails afterwards. This was the crew working together. Thanks for everybody. It was really a great time, a great opportunity. Any question?
I think you already answered one of the questions I had. You mentioned you were using Yang push for some of the measurements and that you had some problems with the measurements, but that was more in your implementation or how you were looking at the information you were gathering. It wasn't like an issue with Yang push or lack of support or anything like that for that functionality.
Exactly. It's basically regarding how the CPU is being used. And there, of course, there are, let's say, different measurement points which are important. And from the hackathon, we learned basically we need to have a deeper look at it.
Okay, great. Well, thank you very much.
Mm-hmm. Great, thanks.
So next up, we should have Logan and for DNSSEC, or perhaps Mitten would be presenting. Okay. Jaitashan is hoping to present. I guess we have an issue with the laptop. If we could go forward and come back to you later if it's something, we'll give you a minute to see if you can get it straightened out. But if not, we can pass by you and circle back at the end. You can let me know in the chat what you prefer. Looks like things are getting sorted. Yeah, we don't see your audio, or sorry, don't see your video. Now we do. And now we just need audio. Yeah, no audio yet. So there's a microphone with a hand on it. If you see that, that should enter you into the audio queue, and then we can enable your audio.
Can you hear me now?
Now we can. Great.
Great. Sorry for that.
Okay, but we don't see, it looks like you have the ability to share your screen, but we're not seeing it yet. If you're, okay, it looks like it's coming up, but we don't see it yet. Did you try to share? You may need to allow it on your computer.
Okay, so I am on the screen queue. I have shared the video queue.
Did you upload your presentation to
Yeah, it is.
GitHub? Let me find it. Okay, I think I see it. Okay, so I'll share the presentation for you.
Oh, thank you.
Okay.
Right. Good morning, everyone. So for this IETF hackathon, our main targets are DNSSEC, TLS, and HTTP3. I am Nitin, member of Cyberstorm.mu, currently working at West Highland Support Services, and deal a lot in the market data industry for more than 20 years now. So as a member of Cyberstorm.mu in USA and together with a team in Mauritius, we focused a lot on the RFC 8624, TLS 1.0, TLS 1.1 deprecation, and quick HTTP implementation. So for DNS mask, we have been deprecating DNSSEC algorithm. PR sent already to deprecate TLS 1.0 and 1.1. Most interestingly, Zabbix, we are enabling HTTP3 now, the HTTP3 support. And HTTP scanner, we are now working for the improvement of the HTTP3 support. And map, myself, I'm working on that to add auditing feature for TLS 1.0 and 1.1 scoring. So the scoring right now is not perfect as per the RFCs. So this is the part that we need to improve a lot for Nmap. So we have learned a lot about backward compatibilities when things break up. Some of us need to compile the basic development edge tools on the system to be able for testing. This takes a lot of time. Our infrastructure needs to be very robust when it comes to rollback, break and fix snapshots. Otherwise, we want to raise more awareness of HTTP3, especially in Africa. And I believe this is a very good opportunity for Africa to get involved for the HTTP3 adoption. Personally, I believe that we have been able to make it on this hackathon itself with HTTP3. And it's a very new thing, but yet we have been able to send some PR already, which is I believe it has been accomplished. For the next IETF hackathon, we are going to focus a lot on HTTP3 adoption and we invite all the developers to come and join us, and we can bring more a robust and secure internet. So congratulations to the new members, Alex Bisesov, who made it into this hackathon. The usual suspect, which you can be seen on the screen, has been here with us for many hackathons now. Alex Bisesov is a 16-year-old guy, and he had been working a lot on script, HTTP3, and for the infrastructure to make us be more forced in the job. He has been helping us a lot. So I'd like to thank Charles, the Meteorco team, everyone during this pandemic, and that yet we are going strong for this hackathon, and keep safe, guys. Thank you.
Great, yeah. Thank you very much for the presentation, sharing it for the whole group there. It's good to see your continued efforts around these protocols. So
yeah.
Glad the online version of the hackathon worked out for you.
Yeah, welcome.
Let me stop sharing. And let me see who's up next then. So next up, we should have Brendan Morin for Suit. Okay, Brendan, you'll have to share your screen, or enter the queue to share your audio video. Great, we can see you. Don't hear you yet. And we don't see your screen yet either. I know, at least for me, my browser asked me to, I need to explicitly allow sharing of the application I'm trying to share. And I have to click allow within my browser. So if the screen share is not coming up, that could be it. And we still have not seen you in the audio queue. So probably where you see the little microphone with the hand on it, you'll have to press that, and that'll put you in the queue, and then we can accept that, and you'll be able to speak. We'll be able to hear you. So kind of top left screen of the screen, right below where it says your participant name, you should see a little microphone with a hand on it. No, we don't hear you yet.
Apparently, I have to restart Firefox to be able to actually share my screen. So I guess I'll be back in a bit.
We can hear you now. Can you hear us?
Yes.
Okay. So to share your screen, you'd need to restart Firefox?
Yeah, apparently it didn't have permission previously. So in order to give it permission, I have to restart.
Okay.
So there you go. I'll be back.
Okay, we'll do the other presentation first, and then when you're back on, ready to go, we'll come back to you, Brendan.
Okay.
Okay, the next two presentations are from Paul, one for IP Wave and one to I2NSF. Paul, I'll leave it up to you as to which one you want to present first. I understand there are two separate presentations. So. Okay, we don't hear you yet, but we can see your screen,
okay,
IP Wave, and now we hear you.
Okay, good. So hello, everyone. This is Paul Jung from Sungkyunkwan University. So I will report our IP Wave Basic Protocols project. Basically, this hackathon, we wanted to implement the context-aware navigator protocol called CMP for IP-based BQL networks. So we want to show the proof of concept of IP version 6 based context-aware navigator protocol over IP Wave. So we want to show IP version 6 mobility information sharing, and also we demonstrated coordinated path planning for obstacle and collision avoidance. So basically, this hackathon project based on IP Wave Internet Draft. The first one is RFC 8691, IP version 6 over L211 OCB. And also we implemented vehicle neighbor discovery. And then we implemented the context-aware navigator protocol based on this open source simulation tools. This figure shows context-aware navigator protocol over IP Wave. You can see some vehicle V2 collide with some obstacle in roadway, and the V1 detected this accident and then disseminate emergency context message to neighbors to avoid these kinds of accident. So they change their maneuver safely to avoid the consecutive accident. So you can refer to the paper. This paper we describe the more detailed information for context-aware navigator algorithm. We extended the neighbor discovery option for vehicle mobility information to contain the vehicle mobility information such as vehicle position, speed, direction, and the driver action such as braking or accelerating. This is the figure network structure in simulator. So you can see multiple RCUs. 3 RCUs are deployed in a highway, and we have MA. MA stands for mobility anchor for mobility management, and the vehicles can communicate with V2V using IP Wave OCB mode, and also they can talk to RCU for mobility management. So we implemented this using OMNet++. This figure shows OMNet++ network simulator. So we have 2 RCUs, and also we have multiple vehicles moving through a roadway and also mobility anchor. So what we got done, so we implemented our context-aware navigator protocol over IP Wave protocol. So we demonstrated. So we implemented a coordinated maneuver control algorithm to avoid collision. So this hackathon, we implemented the CMP, but we didn't separate the vehicle mobility information such as ECM, CCM yet. So we'll separate next hackathon project. So what we learned during this hackathon, vehicle can exchange their mobility information over IP Wave protocol. We modified the INET. INET is internet package for OMNet++ simulator. Also, we demonstrated the maneuver controller can help to avoid collision. And also, finally, it is shown IP Wave can effectively facilitate IP-based vehicle application protocols such as context-aware navigator. So my team has 2 members, my PhD student, BNMA, and the event Chris, and also we had a participant from different universities. Okay, from Songshal University and Gyeongbuk National University, to Delft, and also we had Alex. Alex was he was a main contributor IP Wave, and Yali Wang also joined. So our project is an open source project in GitHub, and also we demonstrated using video clips, so you can take a look. Thank you.
Great. Thank you, Paul. So you're welcome to just proceed on to the second presentation.
Okay. So the Brent, he will present, right? Or I present I2NSF? So either one is fine, yeah.
Excuse me, so you wanted someone else to present the I2NSF?
Yeah, I will present, yeah.
Okay.
So I can go ahead? Okay. So,
yep, yeah, go right ahead.
Okay.
Yeah, we'll go back to Brendan afterwards.
Okay. So, okay. So this is my second hackathon project. Actually, the I2NSF is 11th hackathon from the IETF, I believe 95, something like that, in Seoul. So this hackathon, the plan is we wanted to reflect the latest revision of the following working group draft based on OpenStack-based I2NSF, especially capability data model and consumer-facing NSF-facing interface, and also registration. So we have also security policy translator. This is not a working group draft yet, but this is very important for the I2NSF. So this figure shows I2NSF framework for intent-based networking based security services. So basically, you can see this administrator gives us some high-level policy, and then this policy going to the cloud. So the cloud has a security controller, has translator, and consumer-facing interface data, Yang model-based high-level policy translated into low-level policy that is delivered over NSF-facing interface, and then each policy delivered to appropriate NSF network security function, firewall, IPS, web filter, DDoS authenticator. So we implemented this I2NS system on top of OpenStack-based NFV system. So we published the IEEE Communication Magazine this year, so you can refer to this paper for further discussion and explanation. This time we used this network topology. So we installed the I2NS user as a dashboard system and the security controller, and DMS stands for Development Management System, providing network security function as VM, virtual machine. And then we tested the time-based firewall and the URL web filter. So the time-based firewall, such as the employee just can access SNS, such as Instagram, YouTube, Facebook during work time, cannot access. After work time, they can access. So we used open source, some Linux-based. So minimum specification for OpenStack, we needed to use this RAM storage CPU specification. What we got done, so we restored the I2NSF framework on top of OpenStack again. So web-based ITONS per user, and also console-based security controller and developer management system DMS. And also we used the security policy translator for IBN network, intent-based networking. And also we reflected the latest revision of two young data model, consumer-facing and NS-facing interface data young model. What we learned, we recognize the necessity of a security policy translator to support the following for IBM-based security services. First is automatic mapping between high-level young attribute and the low-level young attribute. Basically, two young modules given to translator, they can automatically map. And the installation, so low-level young production rule can be installed, generation for low-level security policy. So this is not implemented yet, but we are working on. The first one is implemented, and the second one case we designed, we are working on it. Next steps, we want to reflect latest legislation interface, and also we will implement monitoring young data model. So that basically we push out all data young models into the RFC this year. And also we want to enhance security policy translator for automatic setup. So this is my team information. So I have two. First, Patrick is the main player for this hackathon. He's my PhD student, Jae-Hong and Yosop. They also my grad student. And also we had the participant from Songsil University, Professor Young-Han Kim, and Hyun-Sik Yang, and Gyeongbuk National University, Gyeong-Sik, and Manson, Kichakato. So this also open source project. You can also watch our demonstration video clip. Thank you.
Okay, yeah, thank you very much. I just had one question on the Yang model,
Okay.
the mapping.
Okay.
So, did I understand correctly, the one Yang model is kind of more of an intent-based, higher level description, and you're mapping from that to kind of lower level device level Yang model? Is that what's happening?
Okay, so say it again.
You mentioned mapping from one Yang model to another.
Yeah. Okay, sure.
A low level and a high level. And I was curious if the high level one is is that the intent based model at a higher level, and then you're mapping to a lower level device level Yang model?
Mm-hmm. Right, exactly. So the high level case, for example, during a work time, the employee in Cisco, for example, they cannot access the YouTube, such as one SNS site, right? So in that case, basically the network administrator, they don't need to know the IP address of employees and also the SNS website. That kind of information stored in the database security controller. So basically our translator translate the IP addresses of computer and devices used by employees. And also we translate SNS website into specific website such as Google, YouTube, Facebook, Instagram, something like that. So those kinds of map performed. So basically, the first automatic mapping case, we can match such kind of employee into the IP addresses of employees' devices. Okay. Second one is to generate low-level device level security policy. We need to know the grammar structure of production rule to generate low-level Yang tree-based XML file. So currently, we manually store this production rule into database. But next step, we want to automatically store into database for this kind of production rule setup. Is it enough for you?
Yeah. Yeah. Thank you very much.
Okay. Thank you. Yeah. Thank you.
Yeah. Okay. Now we'll switch back to Brendan again to get your presentation. Hopefully this time with screen sharing enabled.
Okay. Thank you. Yeah, Charles. Yeah.
Thanks, Paul. Okay, we can see your screen. We don't see or hear you yet.
All right, I think that's everything.
Perfect, yes.
Okay, good. It's working this time. All right, so I guess I'll start by saying it's a little bit less a participation than I'd hoped for, but that probably has something to do with us having a different hackathon about 11 days ago. We had it on July the 13th. We've already done some wrap up for that, so I won't go through it here. So what came out of that one was that it was clear that we needed to explore a few corner cases in the suit manifest. And specifically, there were a few examples that really do need to be added to the draft. So the idea here was going to be to move that forward. So I did manage to add dependency support, which was good, and got a very long way into figuring out how to optimize the generation of manifests. And discovered a possible missing bit of handling multiple components. And so I had a discussion with some other implementers about that and came up with a new way to handle it. So that's all good too. Yes, I must have jumped ahead of myself. All right. So we have a new implementation that we are proposing to take to the suit working group next week. So that should move things along. And there were a few more people who were interested initially, but in the end, it was really just me and David who kept coming. And David was actually working on something a little bit different. He was working on the implementation of suit manifests for MCU boot. Unfortunately, I haven't spoken to him today, so I don't know how that's going. And that is it from me.
Okay, well, great. Any questions for Brendan? Now would be a good time. Okay, well, thank you for the presentation. The other hackathon, what was that done in conjunction with?
Oh no, it was one of these things where it was set up before this hackathon was announced, and so we figured we'd go ahead with it. And hey, if we get 2 out of the deal, so much the better. But as it happens, it didn't work that way. So there we are.
Okay. All right. Well, thanks for participating and for sharing.
All right. Thank you.
Let's see. I can get my video back up there, and let's see, I think I have a few slides I'd like to share as well. I'm just going to jump back to my presentation here. So we went through the projects, and thanks to all of you for presenting. I really appreciate you taking the time not only to participate in the hackathon, of course, but then to share your results with everyone. And all of the results presentations, I believe all of them are already here. Last I checked, it looked like all of them were. If you had any more updates or that, you're welcome to continue to update these after the hackathon's over. It's just great to have that resource, right? So when people watch the videos, they can go back and see your presentation as well and get all the information there. So thanks for that. Just want to thank our sponsors again. ICANN sponsored several of the last hackathons really appreciate that sponsorship and continued support for us there. And then the Cisco DevNet team just continues to be a supporter as well. So fantastic that we're able to bring these hackathons to everyone. One thing I did want to share as well, actually, I guess I have to stop sharing for a sec so I can share something else. And let's see if I can do that. So I want to call your attention to a survey that we have. And in just a sec, I will show you where that is. It's in the Hackathon wiki. So if you go to the wiki, which has been our source of information this whole week, there is a new link added here, a hackathon survey. It's relatively short. I think it's about 10 questions, especially since this was our first time doing an online version. Would really appreciate it if you could just fill this out. You can see each question has kind of a multiple choice thing that lets us know how well or not well something worked. And really appreciate any comments you have in addition to that. Hopefully we'll be able to hold the hackathon in person again in the future, but odds are good that won't happen right away. In any case, we're learning a lot about how to better, new tools we can use, things we can do to improve when people are remote, especially like the integration between combination of remote and in-person teams. And so, that's going to be valuable. Things that we find that work well, we want to continue to use, even once we do hopefully go back to having our more usual format and the in-person hackathon. So thanks to all of you for joining. For the Techo folks, appreciate all your help with managing the queues. That was great. Let me check and see if we have any other questions. Nope, I think we're good. With that, we'll call this quits. Give you all back the rest of your day. Have a great evening, rest of your day, wherever you are. And yeah, thanks for participating in the hackathon. I'm pretty happy with how things went overall. Hopefully it was good and useful for you. And good luck with the rest of the IETF meeting next week. Yeah, thank you all. Bye-bye.